Hello viewers, today on this presentation we'll be focusing on three topics. The first topic will be based on the treatment of drinking water using ozone. Then the second topic itself will be based on the removal of dissolved inorganic contaminants from water. Then we'll shift over and look at the impact of acid mine drainage upon the environmental water. As we know, South Africa is a water scarce country, so methods need to be put in place, or rather techniques need to be developed in order to ensure that we have good quality drinking water. One method, for instance, such as ozonation, could be put in place. It's a method in which we infuse ozone into water. The use of ozone itself does come with its own advantages and disadvantages. For one, we see that it's very unstable in aqueous solutions, making it rather tricky to treat water. Secondly, we see that it's a very strong oxidant, meaning that it can remove the highest form of pollutant in our water samples. As we look into the ozone system design, we see that as we're treating water, ozone is converted to oxygen. And we know that we can use two methods in which we can convert ozone to oxygen. Either we use a high voltage or high density electrical charge, or exposure to UV light. So this method is very critical to a point that we are increasing the concentration of oxygen and hence making the water quality even more higher. Here are some of the processes that occur during ozonation. Firstly, we have pre-ozonation, then followed by coagulation, then flocculation. Once flocculation is done, we are followed by sedimentation, then sand filtration itself. Then after that, we have the main ozonation, followed by a filtration step and then chlorination or disinfection, in which increases the quality of our water. Like any sword, each and every method has two edges, a good edge and a bad edge. In this case, ozonation is a double-edged sword, for its advantages are very good. However, its disadvantages cannot be ignored. For one, we see that it's a very expensive method, and we know that ozone is very reactive and corrosive if care is not taken. Very toxic gas for one. However, we see that ozone decomposes readily and that the water quality is top notch, making it a very favorable method, even though it is very harmful. So, for this part of the presentation, we'll be focusing on methods of removal of dissolved inorganic contaminants from water. First, the saying goes, water is life, irrespective of the species we're referring to, for we all need water for one. And given the activities that we do, inorganic contaminants will always find their way into our water systems, whether through the sewages or through the pollution from the mining activities that occur. Commonly, in countries that are underdeveloped such as India, Brazil, even South Africa, trace amounts are always found in high concentration upon our water systems. However, scientists have come up with parameters to help better identify if the water quality is good enough for consumption. As scientists, it is important for us to actually identify the problems that are around us, but it is more important for us to come up with solutions to those problems. Here are some of the solutions which we can use to remove these inorganic contaminants from our water. Some techniques such as reverse osmosis, absorption, electrodialysis, distillation, softening of water, precipitation, and coagulation. The method of precipitation has to be the most effective of them all. For one, we're making use of a coagulating reagent such as hydroxide or sulfide, and we're combining it with a sample that contains a polyvalent anion Now, a polyvalent anion is an anion that has a valency higher than 1. So, once we combine the two, we form a precipitate, which then settles at the bottom of a container. And by adding this polyvalent anion, we're also altering the pH and the electro-oxidizing potential of the solution. The precipitate is then filtered off, and then water is reused again. Simple. Here are some of the advantages. For one, it's the simplest method ever. 2, very versatile as it can remove more pollutants. But it does come with its own disadvantages. For one, it requires frequent maintenance, meaning that you have to check on it more frequently, and which is very time consuming. And then optimization of treatment can be very difficult to maneuver. So this method does come with its own good and bad habits. Now in this diagram, we see a clear description of the method of precipitation. We see that the coagulant here is being added to the sample. Then once it's being added, we see that over time it traps the metal ions. Then again they are allowed to settle, which separates it from the water that we have, and then we have clean water afterwards. Now the second method we'll look into is reverse osmosis, which is just a method that we use to separate ions. The ions are actually separated using a semi-permeable membrane. Contaminants are actually pressured into the membrane, and then which the membranes themselves act as filters, and then we have clean water afterwards. Here are some of the advantages and disadvantages. This method consumes less energy. We see that it also achieves high rejection efficiency, making it more reliable. However, it is highly dependent upon membranes, and membranes are also expensive themselves. These membranes also experience fouling, so the filtration may fail sometimes. Here's a description of what happens during reverse osmosis. We see that the water is pressured. As it is being pressured, the contaminants come face to face with the membrane, and then since it is semi-permeable, it allows certain ions to pass through, but others are not allowed to pass through. And as the water flows, we end up with fresh water with the contaminants being stuck at the membrane. The third method we'll look into is electrodialysis. Now, this method, just like reverse osmosis, relies heavily upon membranes, mainly selectively permeable membranes. Now we see that the ionic contaminants are isolated by that very membrane. And once they are being isolated, we see that an electrical potential is applied between the electrodes, and then we get an electrical current afterwards. And then once we get that electrical current, we see that there's an alteration of the ions, and that also forms either a diluted or a concentrated solution of salts. After we get that, we see that also a hydraulic pressure is then applied to help remove the salts. Here are some of the listed advantages and disadvantages of the method. We see that it offers high recovery, meaning we lose less water. It can work over a wide range of pH values, meaning it doesn't matter the pH of the water that we are analyzing or trying to purify. However, the membranes are very expensive since it is heavily dependent upon its membranes, and also it demands a lot of energy, so making it very hard to conduct. For this last part of the presentation, we'll be looking at the impact of acid mine drainage. Now, acid mine drainage has been an environmental crisis for quite some time. Now, the question is, what is AMD? From the picture, we see that there's a pollution upon that water. But what is the source of this pollution? We also see that there's a mine shaft at the back, meaning that mainly AMD is caused by mining activities. And those mining activities end up dumping their waste upon environmental waters. So you see that water sources are actually affected mainly by the recklessness of mining companies, mining activities. We see that also it's the formation of acid-rich water, meaning that we're increasing the concentration of acid content in our water. Now, what is the main cause for AMD? Now, it could be defined in this way. Surface water reacting with sulfur-containing minerals, which form sulfuric acid, or used coal spoilage after the production of electricity from companies such as ESCOM, waste dumped from mining activities. The question is, why is AMD still a problem to this day? Well, one of the reasons is that these mining companies are very greedy. Greedy to a point that they don't care about the impact that they have upon the environment, but rather about getting their pockets much more fatter. This picture here shows an illustration of a mining company throwing its waste directly into a dam. Now, think about the impacts that it will have upon the aquatic life here and those who rely upon this dam as a source of water. Now, here are some of the impacts of acid mine drainage. Upon humans, we can have water shortages as the water supply would have to be cut in order for the water to be treated before being distributed back to the people. 2, it can cause cancer considering that it has heavy metals, and if it's not treated, when we consume it, it will result in a person having cancer. 3, can cause high blood pressure. 4, can cause brain and kidney damage upon the environment, results in a decrease in aquatic life, which brings upon an imbalance upon the biodiversity. 2, the soil becomes acid rich and it makes it impossible for us to plant, and hence will also result in what? Starvation upon humans. 3, it also damages natural water sources, hence making the water undrinkable anymore. 4, also what? The water that they're polluting also affects the animals, as the animals cannot consume that, for if they do, they will die. Now, here are some of the impacts of considering the human aspect. 1, we see that the land is no longer good for farming. It is no longer good because it's acid rich. We see that the water sources now are too polluted and it's not good for drinking anymore. Looking at the environmental aspect, we see that the hippos themselves are finding the water unbearable. And also, we see that the skin of the fish has been affected by the acid in the water, for the acid itself has increased, and hence the fish cannot comprehend that environment anymore. Now, here are some of the ways we can mitigate AMD. 1, we can apply nanofiltration techniques upon water sources. 2, we can use microfluidic screening. 3, we can apply AMD remediation, either active or passive. Here are some of the things we can also look at. Take note of the water smell before consuming it. Boil the water before drinking it. Disinfect it using bleach after boiling. Impose hefty fines upon mining companies for their pollution. Now, all of these are individual roles we can play to mitigate this problem. Now, in order to mitigate AMD, we have to apply some procedures. For one, we can use microfluidic screening, which makes use of microchips to monitor the species found in our water. This process is very versatile to a point that it has multi-screening of different pollutants at once. It is relatively affordable, produces quality screening of both chemical and physical parameters, making it very unlimitable. Here's a figure that shows how this method actually works. It detects any form of pollutant using a microchip and gives off a warning to the system before allowing the water, or rather the pollutant itself, to pass into the main water system. Secondly, we have nanofiltration. Now here's a clear description of how it actually happens. See, it's a very effective method in removing resistant anions. The operation costs are surprisingly low, handles any load of waste, operates well under any condition. The third method we'll look into is acid mine drainage remediation. Now this is a form of precipitation in which a metal is chelated. One, we know that two forms of remediation exist: active and passive. Firstly, we look at the active remediation. This method requires a lot of work and monitoring, very expensive and very extensive. Passive, on the other hand, is the opposite of active. It is very less expensive, does not take much time, and requires less monitoring. It is commonly used for the removal of metals such as copper and aluminum. Passive is the most effective method of removing copper as compared to active. Hopefully this presentation was able to assist, or rather enlighten you about the water crisis that we face and the methods that have been developed in order to treat our water. Thank you again for your time. Goodbye.